Hi, 192.168.10.10. Oh, you thought I was talking to you? No, I was in fact talking to the camera. Believe me or not, in a few years from now, these guys will wage war against us and there will be a judgment day. No, that's too far. But at least these guys have addresses. In the near future, every device that we own will have addresses where we can reach them and ask for a cup of coffee, or we can do more than that. Now, exactly what are these addresses? They are called as IP address. Now, what is an IP address? Internet Protocol address. Now, the version I'm going to talk about is IPv4, version 4. V4 stands for version 4. It is a unique and universal address, which means it is unique throughout the world, and no two devices can have the same IP addresses. For example, now this system has an IP address of 192.168.10.10. As you can see, this is a 32-bit address. Now, computers, they are pretty, not that much good. They do only ones and zeros. But we are intelligent, so we reduce that address into different format called as the dotted decimal representation, which is 192.168.10.10. Now, but how does the computer sees this? In binary format. The 192 is equivalent to 1100, Similarly, 168 is equivalent to 10101000, and then 10 is equivalent to 4 zeros followed by 1010. Similarly, the last 10 is equivalent to 4 zeros followed by 1010. Now that is called as the 32-bit representation. Now each has the address can be split into 4 parts. Now each is an octet, and each octet corresponds to the dotted decimal representation. Right. Now with this address, we have to guess how many IP addresses are possible. Now that is given by the address space. Now the formula is 2 to the power of n, where n corresponds to the number of bits present in the IP address. As you can see, it is a 32-bit representation, which means 2 to the power of 32, approximately 4 billion addresses should be available. Wow, that's a large number, right? But not. The number of devices kept on increasing as the cost of devices kept on decreasing, and I myself have 2 phones with me. So which means the number of devices in every home is going to be huge, and the number of addresses is not going to be sufficient. So we have already started the transition to IPv6, but IPv4 is the base, which will be our part of study. Now the IP address can be split into 2 portions. Now the network as well as the host portions. Now if I take the same example, 192.168.10.10, the first 3 part will correspond to the network portion, and the last part correspond to the host portion. Now what is network? What is host? Now assume I am in our college and a pizza delivery guy is coming to deliver me pizza. Now time is a crucial factor. Within 20 minutes the pizza is going to get cold. He has to find me fast. How? He just knows my name and he doesn't know where I am. So that's where the network and the host portion comes into picture. The first thing, he has to know which department I am, and then he can find me from there. So we have the help of subnet mask to help us to find what is the network portion and what is the host portion. Let me give you an example. The subnet mask will help me find the network portion from this address. Assume that I have 192.168.10.10 and I have represented that in the binary format. Now the subnet mask is 255.255.255.0, and the corresponding binary format is this. So as you know, 255 is all ones. Similarly, 255 is all ones, but the last part is 0 is all zeros. If I have the AND operation, which will AND these 2 numbers correspondingly, you will get 192, 168, 10, and since this is 0, you will get a 0 here. So the first 3 part corresponds to a network portion, which is 192, 168, 10, and the last part corresponds to your 0. The network address is now 192.168.10.0. From that, I can find the host address. Okay. Now we have gone through what is network portion, what is host portion, and then subnet mask. Now it is time to split our network. Now assume I have one network, which is 192.168.10.0. The last part is expanded to explain subnetting. Now I need 2 networks from this network. One is ECE and another is ECEB. Assume the parent network is ECE. Okay. Now I'm going to divide this network into 2. by getting some bits from the host portion. How many networks we need? 2. Which means if I borrow 1 bit from the host portion, I can have 2 networks, because I can change the 0 to 1 and I have a new network. So the first network ECE will have 192.168.10.0.000.0000, and the second ECE network will have 192.168.10.1. That 0 is changed to 1 and then all others 0. You can see that I have written a prefix value from the subnet mask. You will remember the subnet mask for this particular network is 255, 255, 255 is 0. The alter way of representation is /24. Why /24? Because all the 24 bits is 1 in the subnet mask and last 8 bits are 0. Similarly, the new network, I borrow 1 bit from the host portion, which means I have increased the subnet mask as well as the prefix value to 25. Similarly, for ECEA, I have 25 as the prefix value, ECEB, 25 as the prefix value. So my new networks will be, for ECEA, it is 192.168.10.0/25. Similarly, for ECEB, 192.168.10.128/25. Right. As an example of subnetting, I'll subnet the entire ECE network into 2, ECEA and ECEB, with a practical example. I have a router here, which is R1, and I have a switch S1 and S2 individually in each network. The S1 has P1 and P2, which stands for PCs, the end devices, PC1 and PC2. Similarly, S2 has PC3 and PC4. Now, from our example, the entire ECE network is in 192.168.10.0/24. Now, we have to assign this network into 2, which is ECEA and ECEB. From our example, the ECEA network was 192.168.10.0/25. Similarly, the ECEB was 192.168.10.128/25. Now I have to assign the addresses to the individual devices, right? Now this network has a router interface, which means this is the default gateway. When you go to the system and you type ipconfig in the command prompt, you will get 3 values. 1 is the IP address of the system, 2 the subnet mask, and 3 is the default gateway. The default gateway is the point where the entire devices can use to communicate to the other networks or even to the internet. Now, this is the router's interface or the default gateway. I'll assign the first address from this subnetwork to this, which is 192.168.10.1/25. And for this PC1, it is 192.168.10.2/25, and similarly this .3/25. I've reduced this number just for clarity. Now similarly for the other network, the ECEB is 192.168.10.128/25. The first address will be assigned to the gateway of this subnetwork, which is 192.168.10.129/25. The second will be given to the PC3, which is .130/25, and third will be to the PC4, which is .131/25. Now we have created a network, and we can communicate from this network to that network, maybe from PC1 to PC3. If I ping from PC1 to PC3, my ping would be successful. Thank you.